हेलो फ्रेंड्स, टेक्स्ट मास्टर में आज हम सीखेंगे बेसिक कॉन्सेप्ट कॉन्सेप्ट ऑफ oscillator. So we type concept of oscillator and search it. So here we open first link or first website. Here we discuss in detail oscillator basics. Oscillator basics in the most measurement and instrumentation system test setup, electronic troubleshooting, equipment and other electronic systems. Signal generator are essential device which are used to generate different waveform at specified frequency and amplitude. These signals provided by the signal generator used to give an excitation to various electronic measuring devices and producing circuit in order to convert various transducer output into useful information. The excitation from the signal generator can be stable AC or constant DC signal, and also in some cases it is required to vary the amplitude as well as frequency of the excitation. Some of the waveforms generated by the signal generator include sinusoidal, rectangular, triangular, square and pulse waveform. In some applications these waveforms are required to audio frequency as well as radio frequency. Therefore, electronic circuits which generate such type of waveforms with certain magnitude and frequency are called as oscillator. There are different types of oscillators that can able to generate the output at high frequency up to gigahertz. Therefore, electronic circuit which generates such type of waveform with certain magnitude and frequency are called as oscillators. There are different type of oscillators that can able to generate the output at high frequency. Before going, let's consider that understand the basic involved in oscillator circuit. Waveform generate. What is oscillator? An electronic circuit used to generate the output signal with constant amplitude and constant desired frequency is called an oscillator. It is also called as a waveform generator, which incorporates both active and passive elements. The primary function of an oscillator is to convert DC power into a periodic signal and AC signal at a very high frequency. An oscillator does not require any external input signal to produce sinusoidal or other waveform to desired amplitude and frequency at the output, and even without use of any mechanical moving part. In case of amplifier, the energy conversion state as long as the input signal is present at the input. Amplifier produce an output signal whose frequency or waveform is similar to the input signal, but magnitude or power level is generally high. The output signal will be absent if there is no input signal at the input. In constant to start and maintain the conversion process, an oscillator does not require any input signal. As long as DC power is connected to oscillator circuit, it keeps on producing an output signal with frequency decided by component in it. The above figure shows the block diagram of an oscillator. An oscillator circuit uses a vacuum tube or a transistor to generate an AC output. The output oscillators are produced by the tank circuit component, either S, R and C and L and C. for continuously generating output without the requirement of any input from prediction state or feedback circuit is used. From the above block diagram, oscillator circuit produce oscillations that are further amplified by the amplifier. A feedback network gets a portion of amplifier output and feeds in oscillator circuit. Therefore, undamped electrical oscillators are produced by continuously supplying loads that occur in tank circuit. So we back move, and now we get a test review about oscillator in next website. Voltage control oscillator using LM566. LM566 is a voltage control oscillator. Oscillator is required some wireless application. So here we discuss about oscillator IC. So VOC working principle. The wide variety of circuit design can be made in voltage control oscillator using different voltage control electronic components like transistor, vector diode, amps. The figure below shows simple voltage control oscillator using a stable multi-vibrator. In this times constant resistor R1 R2 brought up an external control line. The voltage to use C1 and C2 discharge through R1 and R2 changes with the engine V control. Hence, the discharging speed is increased with the increase of V control. This arrangement changes the base of voltage to which the base of a resistor must give a descent. Therefore, by this CRC element and turn on off end of the transistor alter the operation frequency of oscillator at the output. The other form of circuit of a voltage controlled oscillator is shown below, which is implemented by using two operational amplifiers. It generates the square wave at the output. Those frequencies determined by voltage control. The first op-amp working as an integrator. The control voltage is applied at the input terminal, and due to voltage divider, half of the control voltage is applied at the positive terminal of the first op-amp. Also at the negative terminal, the voltage is maintained at the same level. In order to maintain the voltage drop across the R1 is half the control voltage. When the MOSFET is turned on, the current from the resistor R1 flow through the MOSFET. The voltage, which is now converting into a current signal, changes the capacitor. Therefore, the source this current, the first op-amp must provide a steadily rising output voltage. When the MOSFET is turned off, the current flow through the R1 and has discharged the capacitor. Therefore, the first op-amp falling output voltage is needed. Thus, the output of the first op-amp is triangular waveform. The second op-amp works as symmetric trigger and it accepts the triangular wave as input from the first op-amp. When the input voltage is above the threshold level, then its output VCC acts as output, and if the input falls below the threshold level, output becomes zero. Hence, the square waveform is produced at the output. Voltage control oscillator using LM5666. LM5666 is a voltage control oscillator IC unit which is built with internal circuitry to generate both triangular and square wave signal. Those frequencies is set or adjusted by external capacitor or resistor, followed with the application of DC voltage. The figure below shows the block diagram of LM5666 IC, in which current source charge or discharge the external capacitor and its rate set by the resistor, and also control the DC input voltage for switching the capacitor between charging and discharging. A symmetrical circuit is used as shown in figure. The square wave voltage developed from symmetrical and the triangular voltage across capacitor are provided as output. So, buffer amplifier. Phase lock loop, voltage control oscillator are the important building block of phase lock loop. Phase lock block as the analog block building block used in many digital and analog communication. These are used in clock recovery in many digital and communication systems, also used as frequency synthesizer in televisions and wireless communications system to select various channels. A PLL operates in such a way that the frequency and phase of voltage control oscillator are synchronous with the second reference signal. It is an electronic circuit that consists of a voltage control oscillator, low pass filter, and a phase detector as shown in figure. It is capable of synchronizing or locking with an incoming signal. Whenever the frequency of the incoming signal changes, the phase comparator compares frequency of input with that of oscillator output signal and produce the phase difference signal. This output is filtered in low pass filter and produce the filter output as V control to V control to frequency, V control to frequency, frequency to V control, V control to frequency until frequency reached its minimum below the of synchronizing circuit. So in the synchronizing circuit, the frequency is must be at least less than the input source. So there is a very great applications of VCO, tone generator, function generator, phase log synthesizer to generate variable tones of the production of electronic music. In communication equipment, these are used to frequency synthesizer, clock generator, shift keying, so and so on.